In the last class we discussed about the smelting process, that is reduction of the metals from the metallic oxides. Last one is refining process. Refining process. What do you mean by the refining process? Refining is purification of the metals. That you know that refined term. Refined means purified. Refined oil means purified oil. Why it is necessary to purify the metals? See, in crushing, concentration, roasting or calcination and smelting operation, in all this process, we are converting the metal in the form of the metallic oxide in the last stage, that is roasting process. In reduction process or smelting process, that depends upon the nature of the metals, they are classified into the different category. Whereas the metal that is obtained is in not pure form, it is impure form. What happens if we are directly using the impure form of the metals? What about the chemical reactions or chemical properties? See, if any metal that is obtained in an impure state, it should be purified to 100% or 99.9%. If any impurities are associated with the metal, then they have the ability to form the galvanic cells. Galvanic cells means they are nothing but Daniell cells. Whereas if suppose A and B are the two metals, A and B are the two metals, whatever may be the composition, then dissimilar metals, whenever dissimilar metals are in contact with each other, in the presence of the conducting medium or in the presence of moisture or humidity, then redox reactions will occur. The metal which is less reactive or unreactive acts as a cathodic surface, and metal which is more reactive acts as anodic surface. Therefore, anodic surface undergoes oxidation reaction and cathodic surface undergoes reduction reaction. Therefore, a redox reaction occurs means transformation of the electrons will occur. Whenever metal loses the electrons, then it or gains the electrons, then the metal is obtained in the form of the metallic compound. Again, compounds of the metal. Therefore, the metal obtained should be purified to get the 100% pure metal. For example, copper which is used in our electrical cables, that should be 100% pure. If copper associated with the impurities like zinc or tin, whatever it may be, then redox reactions will occur. Then copper undergoes oxidation reaction with atmospheric oxygen in the presence of the moisture. Therefore, the metal loses its reactivity. What happens when the gold is in impure form? You know that the market gold is two different forms. One is 24 karat gold, one is 22 karat gold. You know that the ornamental gold is 22 karat gold. Ornamental gold is 22 karat gold. This implies that the remaining 2 karat, that is impurity. Whenever impurities are associated with gold, then what happens? Suppose if copper is associated with impurity along with that of the gold, if zinc is present as the impurity, then what happens? Then the impure gold, when exposed to air in the presence of the moisture, the atmosphere has no oxygen. In the presence of moisture only the reactivity will occur. Now gold is unreactive, but another metal which is more reactive with respect to the gold, that acts as anodic area. Gold is cathodic area. Therefore, anodes and cathodes, when they come close together, then redox reactions will occur. Gold loses its reactivity. This phenomena is called tarnishing of the gold. Therefore, gold loses its shining property. This implies that gold undergoes oxidation reaction. Therefore, ornamental gold when exposed to air for a longer period in the presence of the moisture, then shining property gradually decreases. Shining property gradually decreases. Very important property of gold, shining property. You are attracted by the gold because of this reason. You are attracted by the gold because of shining property. Therefore, when gold loses the shining property, then it indirectly impacts that gold undergoes oxidation reaction. Therefore, special care should be taken in order to extract the gold. The gold should be 100% pure. Copper should be 100% pure. That is why when brass articles are exposed to air, brass articles are exposed to air, then that's the redox reactions of the copper elements. Therefore, whenever the pure iron, you are telling that the iron undergoes oxidation, iron undergoes corrosion reaction. No. Pure iron does not undergo oxidation reaction. Whenever impurities are associated with iron, then only iron undergoes oxidation reaction. Therefore, the three different forms of iron, that is the pig iron or wrought iron. You know that the wrought iron is the purest form of iron. Percentage of the impurity. This is called as a malleable iron. Whereas a rough as a malleable iron is very soft. Why impurities are added along with that of the gold? This is because pure gold is 100% pure gold is a very soft metal, very flexible. There is no mechanical applications. What are the important properties of the metals that you know? Property, magnetic. Chemistry, any one of the properties used. With copper, electrical property. Iron, magnetic property. Electronic properties also there. That is the case of the copper. Therefore, mechanical applications, mechanical property, electrical property, electronic property, magnetic property. Important properties of the golds are electrical property of the gold, electrical property, electrical property, electronic property, electronic property, electrical property, electronic property, magnetic property, magnetic property, mechanical property, mechanical property. Useful electrical property, electronic property, magnetic property, mechanical property. These properties of the metals are destroyed whenever metal is exposed to air, when metal is not in pure form. Therefore, when it has no these properties, then metal has no use. Therefore, our objective is to purify the impurities. That purification step is nothing but refining stage of the metals. Refining stage of the metals. Now, what is refining? Removal of the last traces of the impurities from the crude metal after smelting operation or after reduction process is called refining. Removal of the impurities is called refining. Removal of the last traces of the impurities. Removal of the last traces of the impurity. Last traces of the impurities. Last traces of the impurities from the crude metal. From the crude metal. From the crude metal after smelting. After smelting. Smelting here corresponds to reduction process. After smelting is called reduction process. Is called refining. Is called refining. Is called refining. Removal of the last traces of the impurities from the crude metal or impure metal after smelting operation is called refining process. Depending upon the nature of the metal or the nature of the impurities that are associated, the smelting operations are classified into different classes. The first one is the liquation process. Second operation is called as a distillation or fractional distillation. Fractional distillation. The third one is called as a electrolytic refining. Electrolytic refining. Electrolytic refining. The fourth one is that is called as zone refining. Zone refining. Zone refining. Last that is called as a vapor phase refining. Vapor phase refining. In this vapor phase refining, again two methods. That is the first one is called as a Mond's process. Mond's process and Van Erkel method of refining. Van Erkel Mond's process and Van Erkel method of refining. Is it clear? Liquation process, fractional distillation process and electrolytic method of refining, zone refining, vapor phase refining. In vapor phase refining again two methods, one is Mond's process and one is Van Erkel method of refining. One more is that's the last one is that is called as a polling operation. Polling operation. It is not in board exam and competitive exam they will ask. That is a polling technology or polling method. Now what do you mean by liquation process? As its name indicates, in liquation process, that conversion of solids into the liquids. Conversion of solids into the liquids. Conversion of solids into the liquids. Now, usually low melting point metals are subjected to liquation process. Low melting point metals are subjected to liquation process. Whereas next one is low boiling point compounds. Low boiling point metals. Low boiling point metals are subjected to fractional distillation. Fractional distillation. Low melting point metals are subjected to liquation process and low boiling point compounds are subjected to metals are subjected to the fractional distillation. Electrolytic refining. Very pure metals, that is called 100% purity. These metals are used in our electrical cables and electronic devices like that of copper or silver or gold. Otherwise they undergoes oxidation reaction. But the noble metals, very pure metals, noble metals, usually costlier metals, noble metals, costlier metals, these are subjected to the electrolytic method of refining. Then zone refining. In the zone refining, we are extracting either silicon or gallium or germanium. Whereas these metals are used in our semiconducting devices. Whereas the metals which are required for the semiconductors, they are subjected to the refining process of zone refining. Whereas in vapor phase refining, in Mann's process, whereas in Van Arkel method of the refining. There is a nickel that is obtained by means of Mann's process. Nickel that is obtained by means of Mann's process. Here thallium that can be obtained by means of Van Arkel method of refining. Whereas zirconium, this metal is obtained by means of zirconium metal is obtained by means of Van Arkel method. There is a Poling, there is a copper, this metal is obtained by means of the Poling, and also the electrolytic method of the refining. This is about the brief history of how the refining that takes place in case of the metallurgy. Now come one by one. What about liquation? Liquation process. In your entrance exam, they will ask this type of the question. Then liquation is used to obtain dash metal. Where is the low melting point of the metal? You should have the awareness about the low melting point of the metal, where the bismuth and tin and zinc and cadmium, these are the low melting point. Whereas the bismuth and tin and zinc and cadmium. In your entrance exam, they will give which one of the following metal is purified by means of zone refining technology or zone refining procedure. Keep it in your mind. Liquation, as its name indicates, conversion of solid into the liquid. If so many metals are there, A, B, C, D, suppose. If suppose impure metal means it contains impurities. Impure metal. It contains impurities. Impure metal which contains impurities. Impurities in the sense, here it may be suppose A and B or C or D. If A has a low melting point, and B, C, D, suppose they have high melting point, then we can separate A from B, C, D. Whereas A, B, C, D, A is present in larger quantities, larger concentration, higher percentages. Whereas B, C, D, they are present in smaller percentages. Then A can be separated by means of B, C, D by means of liquation procedure. In the liquation procedure, it consists of a liquation procedure. What I mean by the liquation procedure? The liquation procedure. Here the impure metal is placed on the sloping hearth of the reverberatory furnace. Here we are placing impure metal. Suppose A, B, C, D are the impurities. A has a low melting point present in higher amount, higher concentration, present in higher concentration, present in higher concentration. Then our objective is to remove BCD. Our objective is to remove BCD. Then impure metal is placed at the sloping hearth of the reverberatory furnace. We are heating by means of the fuel. Here heating by means of the producer gas. Then what happens? Where that contains A, B, C, D. If A has a melting point, B, C, D, suppose the high melting point. B, C, D, high melting point, and A has low melting point. A has low melting point. Then what happens when a mixture of the ABCD, where the A present in larger concentration and it has a low melting point, then it is fed into the blast furnace, that is a reverberatory furnace. It is fed into the reverberatory furnace and placed to the sloping hearth of the reverberatory furnace and is heated by means of the chemical fuel. Then what happens? When A reaches above the melting point, when A reaches above the melting point, it is liquefied. It is liquefied. B, C, D, they have the larger melting point or higher melting point and they present in sufficient lesser quantities. Then A that flows, A that flows above the melting point, A that flows, A that flows, A that flows, A that flows and collect at the bottom of the reverberatory furnace, bottom of the reverberatory furnace, bottom of the reverberatory furnace. Therefore, A is collected here, A is collected here. Is it clear? Therefore, B and C and D are the impurities that left along with that of the reverberatory furnace. By this method, the low melting point metals like that of the bismuth that I mentioned, cadmium and zinc and tin, these metals usually possess the low melting point, can be purified by using liquation procedure. Is it clear? Yes. That is a physical method. We are not using any chemicals here. This is a physical method. We are using the physical parameter, that is melting point is the physical parameter. Melting point is the physical parameter. Is it clear? Yes. The next one is fractional distillation. Fractional distillation. Fractional distillation. What do you mean by fractional distillation? What do you mean by distillation first? Liquid phase separation technique is called distillation. Whereas the two liquids, whereas the one liquid possesses low boiling point, another liquid possesses high boiling point, then these two can be separated by means of distillation. If the difference in the boiling point is very narrow, very sharp, then those type of the separation techniques are called fractional distillation technique. If the difference in the boiling point is very narrow, very sharp, very minute, then those type of the metals are subjected to fractional distillation procedure. Fractional distillation procedure. Is it clear? Here the physical property. Here this is a physical property. Here the physical property. Physical property. Physical property. Here that is boiling point. Boiling point. In the previous case, it was melting point. In this case, it is boiling point. Whereas mercury can be separated by this method. Mercury. It is the liquid metal at lab temperature, and its boiling point is around 633 Kelvin. 633 Kelvin. Is it clear? Just imagine it consists of one fractionating column. This is called fractionating column, and these two are separated by means of one partition. This is partition. Here suppose the A and B and C, suppose these are impurities. Suppose our objective is to remove A, make ensure that A possesses low boiling point. A possesses low boiling point. Therefore, whenever A possesses low boiling point, these two can be separated by this method. A has a low boiling point. A has low boiling point. A has low boiling point. Suppose B and C has high boiling point. High boiling point. And A present in a larger quantity. A present in larger quantity. B and C present in very smaller quantity. Smaller quantity. Suppose if it contains mercury, at 633 Kelvin temperature, mercury is in vapor phase. Mercury is in vapor phase. Above the boiling point of any substance, the substance that exists in vapor phase, Therefore, whenever the mixture of the mercury with other impurities, like that of the cadmium as impurity, zinc as impurity, whatever it may be, in the extraction of the mercury, we are associated with so many impurities, like cadmium may be the impurity. Make ensure that zinc, cadmium and mercury, they have low melting points, because they are present in 12th group of the modern periodic table, whereas due to the completely filled diatomic orbitals, whereas moving down the group, zinc and cadmium and mercury is a liquid metal at lab temperature. When it is heated above 633 Kelvin temperature, mercury which is in liquid state, that evaporates. Therefore, vapors of the mercury are formed. Therefore, vapors of the mercury are into the next chamber by means of an exit. This is an exit. Here it is subjected to cooling operation. Here this is vapor of the mercury, vapors of the mercury. On cooling, it is free to circulate the cold water around it. Here it is circulated by means of cold water. What happens when the cold water is circulated? Then vapors of the mercury are condensed. Therefore, the liquid mercury is obtained at the bottom of the fractionating column. Is it clear? Impurities with high boiling point, just above the 633. Your objective is to heat the impure metal at 633, sharpen. Then what happens? Just above 634 degrees Celsius, Kelvin, or 635 Kelvin, just sharp increase in the boiling point. Then what happens? The wanted metal, which is wanted metal here? Mercury is the wanted metal, that is subjected to vapor phase. Then the vapors of the metal, they are made to pass into the neighboring chamber by means of an exit hole. Then in the next chamber, it is allowed to cool to the normal by circulating cold water. What happens when the vapors of the mercury are condensed by passing cold water? Then vapors are condensed to the liquid. Therefore, the liquid mercury is collected in the neighboring chamber. The impurities with the higher boiling points as compared to the mercury, they are present as impurities in this fractionating column. Therefore, here we can separate A, here we can separate B and C. These are the impurities. This is about fractional distillation method. Make ensure that liquation method is employed whenever the metal possesses low melting point. Fractional distillation or distillation is employed whenever the metal possesses low boiling point. Next one is electrolytic method of refining. Next one is electrolytic method of refining. Electrolytic method of refining. It is a chemical method. It is a chemical method. Chemical method. Here redox reaction will occur. Redox reaction will occur. Redox reactions will occur. Now, in electrolytic method of refining, here pure metals are obtained, 100% pure, 100% pure metals, or 99.99% pure metals, which the metals which are used in electroplating industry, electroplating industry, electroplating industry. In electroplating industry, we are using copper electroplating, gold electroplating, silver electroplating, chromium electroplating. Whereas the electroplating industry, we are using this type of the metals. Electroplating, we are using this type of the metals. Is it clear? Yes. Now, suppose in the extraction of the copper, suppose in the extraction of copper, it associated with the impurities. It associated with impurities. Impurities like gold as impurity, silver as impurity, lead as impurity. Lead as impurity. Here, the impure metal is taken as anode of an electrolytic cell. Here it requires one anode in electroplating or electrolytic method. Electrolytic method always requires one anode and one cathode and one electrolyte. One cathode, one anode and one electrolyte. Impure blocks of the metal are taken as anode of an electrolytic cell. These are the impure blocks. Impure blocks of copper are taken as a anode of an electrolytic cell. Anode of an electrolytic cell. These are anodes of electrolytic cell. And a very thin sheet of the pure metal, are taken as a cathode of an electrolytic cell. These are thin sheets of the pure metal. They are taken as a cathode of an electrolytic cell. And it is placed in a electrolytic cell. It is placed in a electrolytic cell. Placed in electrolytic cell. The electrolytic cell consists of an electrolyte. Electrolytic cell consists of an electrolyte, and these anodes. These anodes are connected. These are anodes are connected. This is plus in the sense anode, whereas these are connected externally. Cathode of an electrolytic cell. Bunch of cathodes and bunch of anode. Bunch of cathode and bunch of anode. Now suppose this is impure copper, this thick block is called as impure copper. Thick block is called as impure copper. The thin sheet of the pure copper. Now this acts as a cathode of an electrolytic cell, and this is copper sulfate solution, dilute copper sulfate solution plus dilute sulfuric acid, sulfuric acid solution. Because of the common N effect, it suppresses the activity of the copper ions. That is the objective of the dilute sulfuric acid in the electrolytic refining of the copper. Is it clear? Now what happens now? Make ensure that thick rods of the impure metal are taken as a anode of an electrolytic cell, and thin sheet of the pure metal are taken as a cathode of an electrolytic cell. And the electrolyte that consists of copper sulfate solution or respective salt solution. Which metal is taken in as a anode? That is the impure block. That copper, impure blocks of the copper. The same electrolytic salt solution that should be used. That is a copper sulfate solution. In addition to the small quantity of the dilute sulfuric acid solution is added in the electrolytic cell. This is electrolytic cell. This is electrolytic cell. This is electrolytic cell. Now what happens on passing electric current? First, this is copper from anode. Copper from anode. Oxidation reaction. Process that is involved in the removal of an electron is called oxidation reaction. A chemical process that is involved in the removal of an electron is called oxidation reaction. And a chemical process which is involved in the addition of an electron is called reduction chemical reaction. Of course, this is copper, but this is anodic copper, thick block copper. And here across cathode Cu2 plus ions that combine with the electron, copper. Now this is cathodic copper. This is called reduction reaction. That is oxidation, and this is reduction chemical reaction. Redox chemical. As time increases, what happens? The thickness of the impure copper decreases because it undergoes oxidation reaction, where the thickness gradually decreases due to the oxidation reaction, and thickness of the cathode gradually increases, that is due to the deposition of the metal copper. Therefore, across anodic size decreases, cathodic size increases. Anodic size decreases. Anodic size decreases and cathodic size increases. Anodic size decreases. And cathodic size increases. Is it clear? Now, after certain stage, anode completely dissolves, and across cathode the thickness gradually increases. You can remove. This is confirmed whenever the electrolytic solution like copper sulfate, that blue shade decreases. That is physical view. Whenever the blue color intensity gradually decreases, then redox reaction is at the end, completion. Therefore, Finally, anode collapses. Then mud that is present, which is nothing but the waste product that is obtained, that is usually accumulated on here this area at the end. This phenomenon, this substance is called as an anodic mud. Anodic mud is collected. Whenever anode completely collapses, anodic mud is collected at the bottom of the electrolytic refiner. Therefore, this is not a waste product because it contains impurities again. Gold may be present as impurity, silver may be present as impurity here, present in smaller quantity, lead may be present in smaller quantity. Again, this is used in the extraction of the gold or silver by means of cyanide process. We can recover. In entrance exam, very important question. Anode mud obtained at the end of the electrolytic refining of the copper would contains dash noble metals like gold or silver or even some extent to platinum. It is useful product. Yes, it is useful product because we can recover the noble metals by means of the cyanide process. This is about the purification of the metal by means of electrolytic method of refining. Purification of metal by means of electrolytic method. Is it clear? Yes. Now we completed the three important one: liquation procedure, the fractional distillation procedure, and electrolytic refining procedure. Next, obtaining ultra pure metals, which are used in our semiconducting devices. Usually silicon, germanium and gallium. Usually they belongs to 14th group of the elements. Usually 14th group elements are used in this semiconducting devices. 14th group elements are used in our semiconducting devices. Or 4th A group of the metals. Is it clear? Now in Jones refining technique, ultra pure metals are obtained, that is very pure, perfect, that is 100% pure metals are obtained, which are used under electronic media, semiconducting materials. In electronic media or semiconducting material, whereas junctions, you know about the PNP junctions. In this PNP junctions, positive, negative, or NPN junctions, negative, positive, negative. In these, we are using semiconducting metals, transistors in semiconducting metals. Here the principal usage is, here suppose it is impure metal, impure silicon or impure germanium. Now what we are doing here, where we are by means of induction furnace, it is made to pass into the induction furnace. Suppose this is the impure metal in the form of the thick block. Now assume this is a induction furnace. Now small portion of the impure metal is made to pass into the induction furnace. What happens? Now it liquefies. Solid changes to the liquid, that liquefies. When it liquefies, all are present in the molten state, including our wanted metal. All are present in the. When it is slightly removed from that of the induction furnace, then what happens? Very pure metal is located one side, and impurities which are go solidification that moves on the remote end. Therefore, you can cut the small piece and can remove. Where is a pure metal? Again you have to pass the impure metal in the induction furnace or induction coil, what it may be. Then again small portion of the impure metal that undergoes liquefies. When the liquefies, then it is liquid metal is obtained, or then what happens in the liquid metal, across one side we have the wanted metal and across another side we have unwanted metal or impure metal. Again you cut into the small pieces. This method is operation several times until across one side we have very pure metal, across the remote side we have impure metal. Therefore very important one is impure metal is made to pass into the induction coil or induction furnace. Then what happens? The portion of the metal that liquefies, portion of the metal, that part of the metal that liquefies, then the liquid metal, then what is the product that is obtained when subjected to solidification? Very pure metal in one side and impure metal in another side, and we can cut and remove the 100% pure metal. The same phenomena is completes. You made to pass it to the induction coil, again it liquefies and allowed to cool. Then what happens? Across one side you have the pure metal, across remote side we have the impure metal. At the end, one side we have the very pure metal and the remote side we have the impure metals. Therefore impure metal can be rejected. Very pure metals that was obtained, that is used in semiconducting devices, like that of the silicon or germanium or gallium. These three metals are obtained by means of the zone refining technique. Is it clear? Zone refining technique. Last one, that is called as a vapor phase refining. Vapor phase refining. Vapor phase refining. In the vapor phase refining, again two methods. One is Mond's process. Then one is Van Arkel method. Van Arkel method. These are chemical methods. Vapor phase refining is one of the chemical method for the purification of the metal. Depending upon the nature of the metal and nature of the ligands used or nature of the chemicals used, again transferred into Mond's process and Van Arkel method. Mond's process is used in the extraction of the nickel, very pure nickel, and this is obtained in the extraction of the zirconium or in the extraction of thallium. These metals are refined by means of Van Arkel method. In your entrance exam, very important question. Mond's process is used in the purification of dash nickel. Van Arkel method is used in the purification of dash zirconium or thallium. In Van Arkel method, what is Mond's process? Mond's process is one of the vapor phase refining procedure for the purification of the metals. It is a chemical method. When the impure nickel, this is impure nickel, it is heated with carbon monoxide at high temperature, then it gives rise to nickel tetracarbonyl. This is complex compound, nickel tetracarbonyl. It is a complex compound. When the nickel tetracarbonyl, when it is heated at high temperature, then it volatilizes to give nickel and carbon monoxide again. This is very pure one. Here at low temperature it forms, and high temperature it forms, decomposes. High temperature it decomposes. Usually at 180 degrees Celsius temperature, low temperature, not below the laboratory temperature, is around 180 degrees Celsius temperature. It gives nickel tetracarbonyl. When the same one heating at 300 degrees Celsius temperature, then it decomposes to give off pure carbon monoxide is eliminated. What about the oxidation state of the nickel? In your entrance exam, they will give the oxidation state of the nickel in nickel tetracarbonyl. It is in carbon monoxide is a neutral ligand. Therefore, oxidation number of nickel in nickel tetracarbonyl that is equal to 0. What is the oxidation state of the nickel in nickel tetracarbonyl? Oxidation state of the nickel in nickel tetracarbonyl is 0 because carbon monoxide is a neutral ligand. Is it clear? Therefore, impure nickel when heated in a current of carbon monoxide at 180 degrees Celsius temperature, then it gives nickel tetracarbonyl. This is complex compound. Nickel tetracarbonyl. Or you can write it. Nickel tetracarbonyl. Is it clear? Nickel tetracarbonyl. When nickel tetracarbonyl is heated at high temperature, it decomposes because it is unstable, volatile or unstable molecule. This is volatile. Then that decomposes to give off very pure nickel. That is called the Mond's process. Here in Van Erkel method of the refining. What do you mean by Van Erkel method of refining? Van Erkel method. Van Erkel method is also one of the vapor phase refining technique. Van Erkel method. Vapor phase refining method. And also it is a chemical method of refining. Here zirconium or thorium, these metals are obtained by this method. Zirconium and thorium are obtained by this method. Is it clear? Zirconium and thorium are obtained by this method. Here zirconium, this is called as impure zirconium, which is obtained during smelting process. When heated in a current of iodine, then it is called to zirconium tetraiodide. This is called as a volatile compound. This volatile in the sense it is unstable one at low temperature. Zirconium tetraiodide on heating at high temperature, then it gives rise to zirconium and iodine. This is called as a pure metal. Therefore, the basic principle used in our Van Erkel method. Here, the metal is heated in a current of suitable chemical. That chemical may be carbon monoxide or iodine vapors, whatever it may be. Then it is converted into the metal compound which is unstable, which volatilizes, then it leads to the formation of the pure metal. Therefore, unstable and volatile metallic compound on heating at high temperature, then it gives off the ligand, then it gives the pure metal. Therefore, zirconium and nickel obtained by means of vapor phase. Is it clear? It is a chemical method of refining. One is cooling. we are using green poles of the wood. Green poles of the wood. Green poles of the wood. We are using in this method. Here, the impure metal in the form of the molten state. This is impure metal. Impure metal. You place this impure metal. Impure metal. Impure metal in the form of the molten state. In the form of the molten state. Impure metal in the form of the molten state is placed in one container, and it is stirred with the green poles of the wood. And it is stirred with the green poles of the wood. Stirred with the green logs of the wood. Green logs of the wood. Green logs of the wood. Why it is necessary to use the green logs of the wood? Then whenever you place this green logs of the wood in the molten metal, then it leads to the formation of the hydrocarbon gas. It leads to the formation of the hydrocarbon gases. Hydrocarbon gases. Hydrocarbon gases are released. Hydrocarbon gases are released. Hydrocarbon gases are released. These hydrocarbon gases are good reducing agents. Good reducing agents. Hydrocarbon gases are good reducing agents. Is it clear? They have ability to reduce any last traces of the metallic oxide that might have been formed. Therefore, the metallic oxides are converted into the respective metals due to the hydrocarbon gases. Metallic compound or metallic oxide plus hydrocarbon gases. Hydrocarbon gases. Then it leads to the formation of pure metal. It leads to the formation of pure metal. And hydrocarbon gases are get oxidized. Hydrocarbon gases are get oxidized to carbon monoxide and moisture. This is vapor, carbon dioxide and vapor. These vapors of the carbon, that is the vapors are of water and carbon dioxide are eliminated. They evaporate at high temperature. The poling operation, especially copper metallurgy, we are using the poling operation. In the poling operation, in a large container steel tank, you place the molten metal, then it is stirred with the green poles of the wood or green logs of the wood. During this process, the hydrocarbon gases are evolved. Then the hydrocarbon gases are good reducing agent. Then they reduces any metallic oxide that might have been formed during the process of the smelting operation. Is it clear? Therefore, the copper method is refined by means of poling operation. Okay, thank you. This completes about the refining method. Next period we will continue the extraction process.